Wait, can you guys see me? Because I don't think my camera is working today.
Can't see you.
It says that my camera may be occupied to close out the software, so I don't know what's really going on. But, as long as you guys can hear me, I think that's going to be okay. And let's start our class for today. So before we get on to our actual lesson, I'm going to review one of the problem from last class. I believe that there was a bit of a mistake. I'm going to go find the dive here. Okay. So it's this one. So we know that the answer is 3 over 10, which I explained last class, but we're just going to go over the process one more time just in case. And basically, again, using the method that we learned last class, it says that 1/4 of the 5th grade student and 1/3 of the 2nd grade student form pairs, and each 5th grade student could have 2 2nd grade partners, right? So we can just say that 5th grade student is X and 2nd grade students are Y. So again, we have 1/4 X and 1/3 Y. But since that means that there are twice as many 2nd grades as 5th grade students, which means that we're actually going to have to multiply this side by 2 instead of the other side. So that means these two sides are the same, and 1 over 2x is the same as 1/3 y. It asked what proportion of the total number of 2nd grade and 5th grade students had partners. So the denominator is going to be x plus y since there are that many students in total, and the numerator will be 1/4 x plus 1/3 y. So again, let's move back onto this. So since we are asking for y, we can just have x is the same as 1/3 y times 2 equals 2/3 y. And by substituting it back into the equation, we have 1/4 times 2/3 equals 1/3. 1/6. 1/4 times 2/3 is 1/6 x plus 1/6 y plus 1/3 y over x plus y. But then again, x is 2 over 3 y, so that would be 2 over 3 y plus y, and after we expand, by adding them together, we have 1 over 6 plus 2 over 6, which is the same as 3 over 6 equals 1/2 y over 2/3 plus 3 over 3 y, which is 5 over 3y. And now we only have to solve this. We can cancel the two y's out to get 1/2 times 3 over 5 equals 3 over 10. So that was like a bit of a mistake made from last class, and we'll just review it. But do you guys have any questions? If not, we can move on to the content for today's class. Let me pull it out first. And today we're going to be focusing on geometry. Do you guys like geometry? Okay, well, personally, I really dislike geometry. But, if it gets hard, it's, extremely annoying. But it's okay. It's really, important, though. So we have to learn it. That's too bad. It's okay. Did anyone do the preview questions? If you did, please raise your hand in the app. Okay. Perfect. Seems like a lot of you guys did it. So, just in case, to review what you guys did, I'm going to send out a poll so you can let's see how you guys did. Okay. So it looks like most of you were able to get it correct. Does anyone want to come up and explain it for everyone? If not, I'll explain it. So this one is a pretty simple question, but I mean it requires a little bit of calculation. Everyone knows what a perimeter is, right? It's basically just the sum of the side lengths of a polygon. So basically it says that the smaller squares, which is this, has a perimeter of 80 centimeters, which means that the side length is going to be 80 divided by 4 equals 20. And since they are all squares, we can use it to find out what the other squares' side lengths are. So for example, these two, this is going to be 20 plus 20 equals 40. So the second largest square has a side length of 40. And this is made up of 3 of the smaller squares, so this is going to be 60 centimeters. And wait, I'm just going to erase this because it's going to get a little messy. So now we want to figure out what the length of the snake is. So we have 1, 2, 3 20s and 1, 2. So that's going to be 5 times 20. And we have 1, 2 30s. So it will be 2 times 30. Wait, 2 times 60, sorry. And these are going to be 1, 2, 3, 4, 5, which is 40. So 5 times 40. Then by adding it together, we have 200, 120, and 100. So together, it's going to be 420 centimeters. And that's our answer. Now we can move on to the second question. I'm going to send out a poll for this one as well. Wait, sorry. Ignore option E, sorry. Is there a question? Yes?
So like the poll is kind of blocking a few words.
Huh?
I think the poll is blocking a few words
Oh,
for
okay.
me.
Sorry.
Thank you.
Okay, then that. Most of you guys were able to get it correct. Almost everyone, which is great. So for this question, does anyone want to explain it? Okay. Wait, sorry. Let me try to.
So basically the area of the shaded parts on each square are equal, so you only need to find the shaded area of one square and times 2. So I just first halved the area of one of the squares is 100 divided by 2, which is 50, and then minus the part on the bottom at the bottom triangle bit, like which has an area of 4.5.
4.5, yeah.
And then if you minus that, you get 45.5, and you just times that by 2, which is 91.
Okay, perfect. Great, thank you. So that's going to be 91. And now let's move on to our last preview question. I'll send out a poll again. Here we go. Okay. Wait, so almost everyone got it correct, which is good. And this is really the question, because the equation, the formula of a rhombus area is basically just this times this divided by 2. So we have 24 times 10 divided by 2 equals 120. Okay, now let's move on to the actual part of our class. There is going to be, I think, 6 concepts, and I'm just going to explain the concept as we go along instead of saying it all before the class. And it's just going to be different types of simple geometry questions. So let's first talk about perimeter. The first trick of perimeter is translation, and it's usually used when we have like irregular shape that has a lot of that's really complex. For example, like this. And what we have to do is that we have to translate. So for example, let's say the question is asking us what the perimeter of the shape is. So it's going to be just like really complicated or tiring, just like boring to have to add up all of these sides ourselves. Like add up all of these all of these sides one by one. So what we can do is that we can translate. Since moving around the lines doesn't change the perimeter, and it just changes the area, but area isn't relevant here, we can just do something like this. So for example, since this, our ideal shape, is going to want to look like this, right? So what we can do is that we can maybe take this line and move it down here, take this line and move it here, and do the same for everything else, because the perimeter is not going to change. And like this, so you guys get the idea. And that way it's going to make it a lot easier for us to find out the perimeter, because it's going to be a regular shape instead of something that has a lot of that really complex shape, and it's just going to be a rectangle, which is a lot easier for us. But again, the question here isn't asking us for the perimeter, it's just going to be an example for you guys. So according to that, let's do a warm-up first, just so I can assess how much you guys know. And yeah, let's go. Okay. And again, most of you guys were able to get it correct. This is actually really easy. So let's say, obviously D is not going to be the correct answer. And let's say A and C, they're actually the same, because we can just translate these 4 lines to make this. And we can translate these 3 lines up to make something like this. So these two have the same perimeter. And this one, but for C, obviously these two lines, the length is longer than this. So this is going to be longer than both of those shapes. And the answer is going to be C. And now let's move on to the first equation problem. It asks, in the diagram, all angles are right angles and the length of the sides are given in centimeters. Note the diagram is not drawn to scale, and what is the length in x in centimeters? So this is x, and we want to find out the length of that. And it looks quite simple, but first we need to prove that these are parallel to each other. So we can just say, 1 and 1 are the same, so this is going to be a rectangle, and 1 and 1 plus 1 equals 2. So these are also going to be on the same line. And this is 1 plus 1 equals 2. So that means that these two are all on the same line. And then now we can move on to finding x. So this is 6. And this is 1, as you can see from here. So x is just going to be 6 minus 1 equals 5. And that's quite simple. But now let's move on to the next question, and this actually uses more of the translation concept. As shown in the figure, Alexander has arranged several rectangles, each measuring 3 centimeters in length, so this is going to be 3, and 1 centimeter in width, so this is going to be 1, to form a shape. What is the perimeter of this shape? And again, it looks complicated, but we can just translate all of these lines. So by moving all of these lines over here, we can just make a shape like this. A regular rectangle. And what we have to do is just find out the perimeter of this rectangle. So the length is going to be 1, 2, 3, 4, 5, 6, 7 times 3. And the width is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times 1. So that's 21 and 13, which together is 34. And that's going to be this plus this, so the perimeter is going to be 34 times 2 equals 68. Okay, that is also quite easy question. And now let's move on to a practice one. So since this is it isn't a multiple select question, I'm going to send you guys a sketchboard. So okay. Okay. So I looked over some of the answers, and the answer is going to be 64. So please check it yourself if you got it right. And does anyone want to come up and explain? Your name is Melissa, right?
Yeah.
Okay.
So basically, you just move the it's like to the side and up. So you do 5 times 4, which is 20. No, sorry. 5 times 4, which is 20, and then 3 times 4, which is 12. You add that up and then times that by 2, which gives you 64.
Okay, thank you. Good. So that is going to be what the translation concept is like, and it's quite simple. But now let's move on to check the perimeter substitution of equivalents in a square. So since the 4 sides of a square are equal in length, we can substitute one side using another, and it's going to be a bit easier for us. And we can learn the concept by using this example problem. The shaded part is a square, and the perimeter of the largest rectangle is. So what we first need to do is we can set a variable that the square side length is x. And we have a plus x equals 7. And b plus x equals 6. So the rectangle perimeter, this is the large rectangle perimeter, is going to be a plus b plus x. A plus b plus x times 2 plus 2x. And that, by simplifying, is going to be 2a plus 2b plus 4x, which is also 2 times a plus x plus 2 times b plus x. So that's going to be 2 times 7 plus 2 times 6 equals 14 plus 12, and that will be 26. So mainly we can just use an equation and substitution as well as variables to find out the answer. And this is also quite simple because it's just going to all be squares. We can move on to a practice problem. So remember that FD is going to be the same as FE, so you can use that to your advantage. 20 more seconds. Okay. So the answer is going to be 16. Well, congratulations to those of you who got it right. This is actually quite a simple question, but it might be a bit tricky. So it says that AD is 8 centimeters long, and this is a square. So let's say this part AF plus FD is 8. Let's say this is X and Y. And DC is also going to be Y since it's a square, which means FE is also going to be Y. And that means this is X and this is Y as well. So X plus Y equals 8, as we know. So the perimeter of rectangle ABEF is just going to be 8 times 2 equals 16. Any questions? Good. And now let's move on to the third trick of the perimeter, finding the relationship between different sides. For example, this is our exploration problem. Shows that as shown in the figure, identical small rectangles are used to form the following figure. The total area of the shaded part is 648. And the perimeter of the small rectangle is, so since all of the rectangles are the same, then this means that the side lengths are the same and these two are squares. So, and these two squares are also the same, which means that the area of one square is going to be 648 divided by 2 equals 324. And the side length is going to have to be 324 roots, which is 18. And by that I mean 18 times 2 equals to 324, right? So that means that the side length is 18. So as we can see, this 18 is the same as 3 of the small rectangle's width. So that means that the width of one small rectangle is going to be 6. And as you can see from, let's see, here, the side length, like the long side length of a rectangle, the length of the rectangle is going to be 18 plus the width, which is 18 plus 6 equals 24. So the perimeter of the small rectangle is 24 times plus 6 times 2 equals 60. So this concept is a bit easier than the last one because it didn't require that much like trickery. But now let's move on to a practice problem. Now we're going to collect it. The answer is 100. The answer is 168. Great job to everyone who got it right. So, does anyone actually want to come up and explain? If not, then I'll explain it. So, firstly, we know that the side length of the square is equal to the width of the rectangle, so we can just divide the entire figure into many different squares. So by doing that, instead, just do this because it is 4 times the width, and do the same for everyone else. So the total amount of squares is going to be 4 times 4 plus 1 equals 17. And the area of the whole figure is 612. So the area of one square is 612 divided by 17, which is 36. And that means the side length of the square is 36 divided by, squared root equals 6. And this is going to be 6. And we can do the same thing. If we want to find a parameter, we can just do translation again to get this. But in the end, the parameter of the entire figure is going to be 6 times 1, 2, 3, 4, 5, 6, 7. So the side length is going to be 6 times 7 equals 42. And it will be 42 times 4 equals 168 centimeters. Any questions? Great. So we can move on to the next one. Cutting paper problem. So when cutting a geometric shape in the plane by using a segment of a length L, the total perimeter of the two pieces is increased by 2L. And it is also pretty much of a simple concept. Let's say we have this rectangle and we cut it like this, and we know that this is L. Then if we separate those two parts, then the new sum of the total perimeter of the two pieces, which is going to be the sum of this perimeter and this perimeter, is going to be the original rectangle's perimeter plus 2L. So I'll actually explain that later, but it is explain that a bit more later when we have example problems, but it is also quite a simple concept. We're going to do a quick warm-up just so I know what you guys know, and I'll set a sketchboard. answers in the correct. So I feel like most of you guys were able to get it right. It is 3 square decimeters or 300 square centimeters. So does anyone want to come up and explain this one? Okay. Good. What's your name? Because I can't see. Oh wait, you're muted. Like, your microphone? Mm-hmm. So 20 and 15? Good. Hmm? But I can't really hear you clearly. So you said 20 times 15 is 300, right? Okay. And by finding the square decimeters, we can just divide it by 100. Right. So, thank you. That's really good. So now that we know the basic concept of what these problems are going to look like, we can move on to the actual problems. As shown in the figure, there is a rectangular paper sheet with a length of 12 centimeters and a width of 11. So this is going to be 11. Wait, sorry. This will be 11, and this is going to be 12. 12. So we want to cut this paper sheet along the dotted line into 2 parts. The sum of the perimeters of these 2 parts is. So again, we just need to find out what the length of this dotted line is. And by finding it, the way that we find it is at first we know that this, by translating, we can get this is 11. This is 11. And now we just have to find what these parts are. So that's going to be 12 minus 3 minus 4 equals 5. And there are 3. So 5 times 3. 1, 2, and 3. 5 times 3 equals 15. And 15 plus 11 equals 26. So since we want to find the total perimeter, that sum of the perimeter of these 2 parts is just going to be 26 times 2 plus the perimeter of the whole rectangle, which is 12 plus 11 times 2 equals 46. So that's going to be plus 46, and we have 52 plus 46 equals 98. And that would be 98. Question? Okay. Now, this is a more of a complicated problem. As shown in the figure, a square paper with a side length 5 centimeters is divided into 5 rectangles along the dotted line. So we can just assume that they are the same length and that they are all 1 centimeter of width. Then moving the 4 rectangles marked by arrows in the indicated direction and length, the perimeter of the resultant figure is. I'm gonna isolate this question real quick. So it says that firstly we need to translate the first rectangle 2 centimeters to the right. So in order to be able to visualize it better, we can divide those 5 centimeters into 5 equal parts, like this. Okay. So it says that the first rectangle is translated 2 centimeters to the right. So we can do, going to look like this, and 2 centimeters. So it'll look like this. Then the second is translated 2 centimeters to the left. So we'll do the same thing. Connect these. The third is translated 1 centimeter to the right. So, like this. And the fourth is translated 1 centimeter to the left. And like this. So now let's connect the line. And the last rectangle did not move, so it'll just look like this. I'm gonna try and move it. And it's gonna be a little hard to look at, but no. So our figure is going to look like this, and we need to find what the perimeter is. It looks a bit complex, but again, we can just do translation as I taught you guys before. So firstly, we know that this is 5, and this is 5. 5. Wait. Bigger. So we know that both lines are 5. It's going to be 5. And these are also all going to be 5. So now we have 20. And the only thing we need to focus on is what these lengths look like. So this is going to be 4, because we have 1, 2, 3, 4. And that'll be 4, which is the same for this. So now we have 4 times 2 equals 8. And these are going to be 3, because 1, 2, 3. So 3 times 2 equals 6. These are 2. So 2 times 2 equals 4. And lastly, we have 2 1s. So that'll be 1 times 2 equals 2. And now we just have to add all of these up, which is 8 plus 6 plus 4 plus 2 equals 20. Plus the 20 that we already have, the answer is going to be 40 centimeters. Any questions? If not, then let's move on to one of our practice problems. The practice problem is not going to be as complicated as this one, so it's okay. Pull it up again. This. time to collect. The answer is 72. A lot of you guys got it correct, which is good, and congratulations. So this is going to be similar to the first problem that we did in the exploration. The solution is going to be, first there is a square piece of paper with a side length of 10 centimeters. So it's going to be 10, 10, and the entire perimeter is going to be 40. So now we just have to find the length of the dotted line. The dotted line, by using translation, we have these lines, and we can translate them to have this line. And the length is going to be 10 minus 2 minus 2 equals 6. And for the length of these lines, it's just going to be 10 by translating. So it's going to be 10. And in the end, we have 10 plus 6 equals 32. And wait, 10 plus 6 equals 16, but then we have 16 times 2 equals 36. And wait, 32, sorry, again. 32. And 32 plus 40 equals 72. So the sum of the parameters of these two smaller pieces is going to be 72. Any question? So now I believe that it is time for a break. We're going to 5-minute break. You guys can turn off your cameras and go get some water, and it'll start. Okay. Okay, time's up. Okay, so back. Great. So let's move on to the last two concepts, and these are going to be slightly harder than like the previous one. And mainly it's going to be about area. So just in case you guys know what like all of these basic polygons areas are, let's say we all know what rectangles, squares, and triangles formulas are, right, for area. So firstly we can do trapezoid, although I'm sure that most of you guys also know what trapezoid formulas are. So let's say that for a trapezoid area formula, it's going to be this is the height. So it's going to be the top base plus the bottom base times the height divided by 2. So that's going to be that. What is it for a trapezoid? And a parallelogram is just going to be the same as a regular rectangle. And a rhombus is going to be this times this divided by 2, which we have also gone through during the preview. And for shapes such as pentagons and hexagons, it gets a bit more complicated. But usually we don't really like talk about that when we're doing regular polygon. But basically what we have to do is find out the areas of divided into different triangles, and then add up the triangles. So that is going to be a little bit more complicated with more involvement of Pythagorean theorem. But so today we're not going to focus on that. Let's do a warm-up on trapezoid. Just stand it out quick. So correct. Most of you guys were also able to get it correct. The answer is going to be 30. So the way that we do this is that we know this is 8 and this is 2. So if we want to find out what the area of the trapezoid is, we have to add these two sides up, which is 2 plus 8 equals 10. And then 10 times the height, which is 8 minus 2 equals 6, is 60 divided by 2 equals 30. So this is a pretty simple one. And now let's move on to our exploration problem. So the concept is substitution again, which is also the same thing that we learned in perimeter. So the way that we do this is we say there's the right trapezoid ABCD in the following figure, and Justin makes a new trapezoid EFGH along the leg AD, create the overlapping parts of trapezoid EFID. I'm going to use red to highlight this part. Given that the two right trapezoids are identical and CD is 14, and since they're identical, it means that HG is also going to be 14. And IG equals IC equals 6. 6 and 6. What is the area of the shaded part? So usually when you see this type of problem, our first instinct would maybe to create a full trapezoid like this, right? However, the thing is that we don't know what AB and H, let's say this is O, we don't know what AB is, so we can't use this method. I'm gonna delete it. The way that we do this is that the area of the shaded part is going to be trapezoid ABCD minus trapezoid EFID. So this is what we want to get, right? But we also know that ABCD and EFGH are identical, so we can just substitute that in, and we can just do EFGH minus EFID. And that is just going to be this part. So we just have to find out the area of this trapezoid. So the way that we do this is going to be ID. ID will be 14 minus 6 equals 7. And we know that HG is 14, so 7 plus 14 times the height, which is 6, divided by 2, equal 21 times 3, and that will be 63. Wait. Wait, sorry. It's 8, not 6. 14 times minus 6 equals 8, sorry. So that will be 8 plus 14 times 6 divided by 2 equal 22 times 6 divided by 2. Now our answer is going to be 66. So the area of the shaded part is 66. Any questions? If not, let's move on to the next problem. It's going to be our practice problem. And again, this kind of part is a little bit tricky. I'm going to send it out to you guys and give you a few hints. So the thing is that it says the side length of square ABCD is 10. So it's going to be 10, and EF is perpendicular to AD, and the area of triangle AGF is 40. So we know that the way we get the area of a triangle, we can say we divide this up into two parts. So the area of this part is going to be HF times EA, and the area of this part is going to be HF times DE. So that's one of the hints that I'll give you, and you guys can try to work on it yourself. Okay, about time to collect. It looks a little bit difficult, and it's kind of like a bit tricky, so I'll explain it for everyone. The answer is 2, and good job to those who got it correct. So I'm going to re-explain the part that I just did. the side length of square ABCD is 10. So AD is 10. It says that the area of triangle AGF is 40. So the triangle is 40. How long is EH? So as we can see, EH is EF divided by, EF minus HF. So if we want to find EH, then we can just find what the length of HF. And as you know, EF is going to be 10. So the way that we do this is that we can divide this triangle AGF into two parts, like this. So it says that the area of this triangle is going to be HF times EA divided by 2. And the area of this triangle is going to be HF times ED, this part, divided by 2. And together, the area is 40. So as we can see, EA plus ED is the same as AD, which is 10. So we can just say HF times 10 divided by 2 equals 40. Therefore, HF times 10 equals 80, and the length of HF is 8. And as you know, EF is 10, so EH will be 10 minus 8 equals 2. Are there any questions? If not, then we can move on to our final practice problem. Another practice problem for you guys. But this one is a little bit complicated, so I'll just explain it directly since we also don't have that much time left. So calculate the area of the shaded part of the diagram, which is this. So as shown below, I'm gonna separately draw it. So this is our shape. We have this look like this, and in mine it looks like this. So the area that we find is this, right? So it is going to be this minus the entire circle equals the part that we want to get. So we can divide this circle into two parts. We can, therefore, that will be this shape minus one semicircle minus another semicircle equals what we want. So again, that is substitution. The way that we do this is that we can just divide both circles into semicircles to get something like this. So that means the area of the shaded part is going to be the same as the area of this part. I'm going to actually highlight it in red just so you guys can see better. So we just have to find out what the area of this is. So let's say that the diameter of the entire shape is line L. Then it is 3 because basically the diameter of the circle, let's say it's D. Then L is going to be, then 3 is going to be L minus D. But since we have two semicircles, so this part plus this part is going to be the same as the diameter of one entire circle, which means that the part in the middle is going to be the same as line minus D, which is 3. So the area of the shaded part will be 3 times 10 equals 30. And that's what we get via substitution. Any questions? Yes? Wait, I can't really hear you.
Triangle is equal to the shaded part.
Oh, okay, I'll explain that part again. ways. So basically, it says that the shaded part is so this is the whole shape, right? And this is, let's say this is one circle. So the shaded part is going to be the whole shape minus one circle. And we can divide that circle up into two semicircles. So the shaded part is also going to be the whole shape minus two semicircles. The area is going to be the same. And we can just divide both of these circles up into two semicircles, which are going to be this. So that means that the area in the middle is going to be the same as the shaded part. Get it?
Okay.
Great. So we have 10 minutes left, and we can move on to our last concept. So this one is actually quite complicated. I mean, not really that complicated, but it's a bit difficult compared to the rest. As shown below, the perimeter of quadrilateral ABCD is 50 millimeters. Point P is inside quadrilateral ABCD, and line segments that originate from P are perpendicular to all of the sides of the quadrilateral. So the first question asks us if you connect P with the four vertices of quadrilateral ABCD, what shapes can you get? So let's just create some lines, see what's going on. This. Sorry. And it will look something like this. So yeah, now we have a bunch of triangles. And let's move on to the main problem. It says that given PE equals PF equals PG equals PH is 8 centimeters. Let me rate this. What is the area of quadrilateral ABCD? So that means that these are all going to be 8. All of these are 8. So it asks the area of quadrilateral ABCD, and firstly we know that the perimeter of the quadrilateral is 50 millimeters. So the way that we find out the area is that we have to add up the area of all of the shape within, right? But how can you find that? So firstly, since all of these line segments are perpendicular to the side, and that means that these are also going to be right angles. And since they are right angles, we can do some, I'm gonna screenshot it. Screenshot the shape. So we need to prove that these sides are the same. And the way that we do this is that we can create a line like this. So we know that these two lines are the same, right? They are all equal to 8. But that means that this is an isosceles triangle. And that means that these two angles are going to be the same. And since the big angles are also the same, they're both 90 degrees, and this means that these two angles, I'm going to use red, these two angles are also the same, which proves that this side is the same as this side. So this applies to all of the other sides, which means that FB is going to be the same as EB, AE is going to be the same as AH, and HD is the same as DG. So we can just use substitution again. Let's say that DG equals A, as you can see here, then DH will also be A, and this is B, then this will also be B, and applying to all of the above, then we can get something like this. Now let's move back onto the actual problem. It says that the perimeter of quadrilateral ABCD is 50 millimeters. So that means that 2A plus 2B plus 2C plus 2D equals 50. And we know that A plus B plus C plus D will be 25. But firstly, it asks us what the area of quadrilateral ABCD is, and we have 8. So we know that these are all going to be 8. So the areas is going to be 8 times D. So for example, this triangle, the area is going to be 8D divided by 2, and this is also going to be 8D divided by 2. So the total area of this shape by itself is just going to be 8D. So this will be 8A, 8B, and 8C. So now we just have to figure out what 8A plus 8B plus 8C plus 8D is. And since we know that 2A plus 2B plus 2C plus 2D equals 50, then we can just times this by 4, and we get that the answer is 200. Therefore, the area of quadrilateral ABCD is 200. Any questions? Good. So let's move on to the next problem. And it asks us that the perimeter of quadrilateral ABCD is 35 centimeters, and the distance from point O to each of the sides of the quadrilateral is 2 centimeters. So it's just going to look like this. 2 centimeters. Sorry. We'll be assuming that it is perpendicular. What is the area of the quadrilateral? And by using the same formula that we used in the previous question, like this, it's just going to be 35 times 2, which is this, divided by 2 equals 35. We can just use it as a formula. And lastly, we have one last practice problem before class is over, so you guys can have an attempt at it. I'll go down. And there we go. I have to give guys 2 minutes because there isn't that much time left. So about time. I feel like surprisingly a lot of you guys are able to get it correct as well. And the answer is going to be 30. So as you can see, I made some lines here. So the area of the entire pentagon is just going to be all of these triangles added up together. So it says that the total area is 120. So we can just say each of the triangle is 120 divided by 5 equals 24. let's just assume, okay, because they all have the same side length anyway. So this is going to be, so let's say that this line is just going to be 8 times this line divided by 2 equals 24, which means that 8 times this line is times, let's say this is x, equals 38. Then x would be 6, and applying the technique to all of the other lines, the final answer is going to be 6 times 5 equals 30. Or you could just say that the length of all of these added up, let's say that the length of all of these added up is s, then s times 8 divided by 2 is going to be 120. So it would be 120 times 2 divided by 8 equals 30. So yeah, that's our final question. Any questions? If not, then congratulations. That is all for our geometry class today. I'm going to upload the homework into the WeChat group and on class in after class. So yeah, thank you guys for listening, and that will be our class for today. See you guys next Saturday.